Hello viewers, welcome to today's lesson. Today we are here to talk about standard form. So what is standard form? The concept, what is it about? Now have you realized that if a newscaster would like to talk about the number of sand particles around the beach and starts quoting the figures 347321755, it doesn't really make sense. The figures are too many. Not everybody will understand. So we have shorter ways of writing bigger numbers to look smaller. And that is what the concept of standard form is. So let's get ready for the subject and then move to this standard form topic. Make sure you are with me, follow up, and let's see how best we can help each other. All right, so we are in standard form. Because our system, we are already working in base 10. If you don't know, let me tell you, we have from 0 to 9, we have 10 digits. So we are already in the base 10 system, meaning that we are operating under 10 symbols, okay? So this numeration is what is going to help us to represent bigger or very, very smaller numbers in a shorter way. So first of all, let's see what the standard form, what is standard form? All right, so let's look at the definition. We are saying that a standard form is any number that is written in the form a dot b times 10 raised to the power c, where the a lies between 0 and 10, or we can say that a is greater than or equal to 1 but less than 10. And then the c is an integer. What's an integer? We have positive, negative, and 0. So any number that is negative, 0, and all positive numbers are what we call integers. So for every number, we should be able to write it in a standard form. Now, we are going to look at the concept. Remember, we are saying that it's in the form a dot b times 10 raised to the power c. This dot is a decimal point. It means that whatever figure you are going to have, you are going to express it such that the first number is less than 10. So let's pick an example. In our first example, we've been asked to convert 200 to a standard form. All right, so 200 to a standard form. Well, let's look at it again. I said the first thing we have in mind is to write the number in a shorter way. So this 200, we are going to have a smaller way to write this 200. First, the decimal is supposed to happen between the first two non-zero numbers. So the first two, so between this and that, we are going to put the decimal there. So we count from the back here, 1, 2, we put it here. So we have 2.0 times 10 raised to the power. How many times have we moved from the right to where we place the decimal point? So let's go through. We have 1, 2. And this is going to be positive 2. And why is it positive? Now this figure was 200. It has been reduced to 2. So this 10 raised to the power 2 talks about the figure actually being 2 times 100. And so this is the same as 200, but it has been written in a smaller form. All right, let's pick a very big number and see how standard form really works. Wow. Now, we have the number here. The digits are 3458792. It has to be converted to a standard form. Now, people be asking, why are we always starting from here and not from this side? Remember that in decimals, we say that any number is the same as the number 0.0. So it means that this number already has a decimal point, which is here, 0.0. We are not going to write it. Now, in changing to a standard form, we are going to move the decimal to the first two non-zero numbers on our left. So how many times are we going to move? We have 1, 2, 3, 4, 5, 6. We have 3.45 times 10 raised to the power 6. What happens to the rest of the digits that are not showing here? These figures have a very small difference. In writing very big numbers, we are trying to do a rounding up so that we can really get very close without writing every digit. So the concept of standard form is to write a number that is so big in a shorter way so that it's very easy to work and to talk about. So here we had this number. Let's look at the figure in question. We have the periods here. So the number was actually 3,458,792. Now we can state it this way. In a news interview, you could hear 3.45 times 10 raised to the power 6. And that would be the number of maybe sand grains along one particular beach. So this is our concept. Now, if you look at all the examples that I'm giving, these two examples, the figures first did not have a decimal point. So I asked, if a figure has no decimal point, why are you introducing a decimal point? I'm saying that every number can be written with a decimal point. All we have to write is that if the number comes and it's a whole number, we have 0.0. Meaning that the number 2, if you want to introduce a decimal, you can write it 2.0. So any number without a decimal can be written as a number with a 0.0. So when you are moving, you are now going to look at where the decimal lies and be moving to where the non-zero number comes in. All right? So the first two non-zero numbers, that is where the decimal point will come in. Let's pick another example. All right. At times, the question, you might change the wording. Instead of saying that convert this figure to a standard form, you can also be asked to change it to index notation. This is the same thing. Don't panic. Either you are going to have it in a standard form, scientific notation, or index notation. So here, we are going to change it. This figure has no decimal point. So it means the figure already has a decimal point of 0. So let's write it so that we can see the decimal point clearly and then move the decimal point. All right. Now we have introduced the decimal point. So now you see where the decimal is coming from. But look at where the decimal point is. Is it between the first two non-zero numbers? No. These numbers are not 0, but the decimal point is not happening there. So we are going to pick the first two non-zero numbers and push the decimal point to that side. So we are going to do the movement. How many times? We have 1, 2, 3. So now we have 3.456 times 10 raised to the power. What number? The number of times you have moved. So we've moved 1, 2, 3. So we have positive 3. Why is the 3 positive and not negative? Just imagine this figure can still be converted back here. Now let's look at why these two figures are the same. All right, so we have 3.456 times 10 raised to the power 3. We would like to see if these figures are the same. So I'm going to work on how to convert this one to get this figure back. All right, now we have to change this decimal to a fraction. Now we are going to change to a fraction, so we first have to know the number of decimal places. How many decimal places do we see here? We have 1, 2, 3. That means it's out of 1,000. And 10 raised to the power 3 means that 10 by itself 3 times. So 10 by itself is 100 times another 10, we have another 1,000. We can now simplify. And we have our 3,456 back. It means these two figures are the same. So what we do in standard form is not to change the number. All that we are trying to do is that we are expressing the number as a decimal part and a 10 raised to the power something. So it will be a product of a decimal and 10 raised to the power the number of movements that we've made when we're moving the decimal point. Okay, now these figures, what if a figure contains a decimal already and it's not at the extreme end, like this one where we have to introduce 0.0? Okay, here we have convert 13.46 to a standard form. This figure already contains a decimal. It means the decimal which was supposed to be here has been moved already. So we have to move it to the right place. And it's not at the right place at the moment. I said it's supposed to be between the first two non-zero numbers, meaning between the first two numbers on your left which are not 0. So it means the first number cannot be 0. All right, so we have to move how many times? Only one. So we are going to have now anytime a bigger figure is reduced, now this figure is 13 point something. So the 13 is the whole number. Now we are writing 1 point something. It means that the power of this 10 raised to the power will be always positive. So we move 1, we have 1 here. Move 1, positive 1. Now people are always making an assumption that as we move towards the right, these figures become positive. That is true, but you have to prove it mathematically. And so the mathematical explanation is that a figure which was 13.46, if you are now going to reduce it to 1.34, then it means that this figure was having a positive power for the 10. Okay. Our subsequent example. Now we have our question here. Convert 120.113 to a standard form. Okay. 120.113 to a standard form. How are we going to do it? First, observe where the decimal point is. Can you see the decimal point? Finally, we can see it here. Good. The next thing is to move the decimal point to the first two figures on your left, which are all not 0. The second number can be 0, but the first number cannot be 0. And this one is coming from our concept. The A should lie between 1 and it should be greater than or equal to 1 but less than 10. It means for every standard form question, the first figure that comes before the decimal point should be less than 9 but should be greater than 0. So from 1 to 9. Okay, so let's do the movement. We have okay. So today we've gone through how easy you can represent a very big number in a smaller way or write it in a scientific notation. Okay? Now what if the number is very, very small? For example, we have 0 point so many zeros. Okay, let's go to the example. Good. Here we come in with working on these. Now, convert 0.000056 to a standard form. This figure is very small. 0.0 is not even closer to 0.1. So it means it's very close to 0. But we can write it in index notation. But once the figure starts with 0 points, definitely we know that the 10 raised to the power is going to be negative. And the negative is going to describe how small the figure is. Okay, so let's look at the number of times we move. We said this point would have been at the right place if this side was a whole number, was a counting number, sorry. Now, we are going to move it till we get to the first natural or counting number. So let's do the movement. We have 1, 2, 3, 4, 5. 5.6. And this part is going to be negative 5. Let's take a look at it again. We have 0.000056 to a standard form. We are saying the first number that comes in the standard form answer should be from 1 to 9. It shouldn't be less than 1. It shouldn't be greater than 9. So when we get here, we have 5 points. If you move it here, we have 56 points. That is way bigger than 9. So the decimal point is supposed to be here. Now we have 5.6 times the number of movements. The figure was very small, starting with 0 points. It means our power here is also going to be negative. Let's try another example. All right, so here we have convert 0.002 to a standard form. Now, how do we do that? First of all, the number that comes before the decimal point should be less than 10, but not less than 1. So here, the first number before the decimal point is 0. It means there's something wrong with the work. We have to move the decimal. The figures are here, so let's move to the right. We have good. If you put the decimal point here, we are still going to have 0 points. So we have to move it over this 2 to this side. Now we have 2 points. There's no number here. You can write 0, and it's the same as 2. Times 10 raised to the power. How many times have we moved? Was the figure a smaller figure? Yes. And so we have 2.0 times 10 raised to the power negative 3. This is the concept. Now we are going to look at how this concept applies to operations. What if you have just one single number and you've been asked to change it to a standard form? Wow. Like I told you, standard form has 2 parts. We have the decimal part and then the 10 raised to the power part. So this particular figure, we have 3. Now this 3, we are now going to look at where the decimal is. So let's first give it a decimal because it has no decimal. So we are going to write 3.0. The decimal is at the right place. The number that comes before the decimal is more than 0, less than 9. So what do we write for the times 10 raised to the power? Okay, let's look at this. Okay, so why have I written 10 raised to the power 0? Now, anytime there's no movement, this describes the number of movements you've made. And because I've not made any movement, it's going to be 10 raised to the power 0. And the reason is this figure here and this are the same. 10 raised to the power 0 is 1. If in our previous video, I described in indices how you know the number raised to the power 0 is 1. And it means the number being divided by itself. So from that concept, if you've read my previous video, you are really going to apply a lot of things as we go through. All right, so we have 3.0 times 10 raised to the power 0. And so when you have a standard form question where you have a single answer or a single digit, which is non-zero, and you've been asked to change it to a standard form, you just multiply that number times 10 raised to the power 0 because you are not going to make any movement. That's good. All right, now we are going to look at operations. How do numbers which contain standard form add up? So let's move on to that. All right, so we are now moving into operations under standard form. So take your time, look at it, and let's move on. All right, standard form addition. Now these figures, we are asked to, first of all, add them. So we are going to add them. Now I'm going to write them in a column form and do the addition. Remember, we can only add when these 10 raised to the power are the same. All right, so we write only one of these, and then we move on. 5 plus 6, we have 11. So 1, remainder 1. In addition of decimal, the decimal points are supposed to be in line. 1 plus 2 plus 3, we have 6. So this is our final answer. Now, what shows this answer is correct? So let's try and prove it. All right, I'm going to write this one in a way that showed before the standard form conversion. This number had been written in a standard form. Now, because it's 10 raised to the power 3, it means the number was a very big number. How many times did we move? We moved 3 times. I'm going to move 3 times back for you to see the actual figure. All right, so that is a 3 times movement. And then let's fill these places which are empty with zeros. Wow. So it means that the first number that we saw, 2.5 times 10 raised to the power 3, is the same as 2,500. I'm going to do the same for the second number here. The positive means that we're moving from right to left, or the number was bigger, so we have to extend it. Now, this number looks smaller. This power is going to help us arrive at the actual number. We are going to move. The 3 here means the number was bigger, so we have to go this way. Okay, now let's move. Good. And then we fill these places with the zeros. Okay, so it means this work that we are solving was actually 2,500 plus 3,600. Let's do the addition. Wow. Now we have 6,100. Let's convert our answer to a standard form and see if it's the same as this particular work we've done here. Now, let's introduce 0.0 because there's no point, 0.0 here, and move. Wow. So it means they are the same. So if you can't work with this, you can actually look for the number that you were supposed to work with. You pick the actual number without a standard form, you change this one to the real number without a standard form, and then you add them. But it means that it's going to be a longer process because after that, you are supposed to change your answer here to a standard form. Okay, we'd like to go through again. We're given 2.5 times 10 raised to the power 3 plus 3.6 times 10 raised to the power 3. The first thing is you have to make sure the 10 raised to the powers are the same. I'm talking about these two. Make sure they are the same. Now, this example is our first example. So I made sure they were the same for you. In our subsequent examples, they are not going to be the same. We are going to change them, make them the same, and then perform the addition. All right. Then what did I do? I wrote it in a column form this way. Wrote only one of these to represent the 2. And I did the addition for this part. Remember, this side is a multiplication. So our answer now is 6.1 times 10 raised to the power 3. Let's pick another example. All right, let's look at this example. Add 3.62 times 10 raised to the power 2 plus 400. This is in the standard form. We are going to change this one so that we can get 10 raised to the power 2 from this. So it means we are going to move only 2 times from the right. So let's introduce our point and move. Good. All right. Now, our first step is we've made sure the power of 10 both of them have is the same. So now we can add. We write only one of these. Then we add the decimal part. 2 plus 0, we have 2. And 3 plus 4, we have 7. Good. Now we've added them. This number had 10 raised to the power. This one didn't. We had to create it, make sure they have the same number of decimal places, and then we add them. Now we are picking other scenarios as the work gets more interesting. All right, so here we are supposed to add 3.5 times 10 raised to the power negative 3 plus 0.0012. So I've told you the first thing to do is to make sure that this 10 raised to the power, they should have the same 10 raised to the power. Now, the figure here is negative. And so definitely we know when we move from the left to the right, we make the figures look bigger. And so they are going to have a negative index. Okay, so let's do the movement for the second one. How many times are we going to move? We are going to move 3 times because we are comparing with this. So now we have good. Now this power for the 10 are all negative 3, and so it's very easy to add. So we'd like to do the addition. So please follow up. All right, let's do the addition. Now we are going to write only one of these with the times to tell the number of times they are happening. So we have here. And let's do this simple addition. 5 plus 2 is 7. 3 plus 1 is 4. And this is our final answer. So for those of you now you're at home, you can really check with your calculators and see if our answers here are right. Good. Let's follow up. Now it's getting more interesting.